Welcome to GIS4Health, the essentials to get you started. Hello, I'm Justine Blanford, Professor of GeoHealth and author of Geographic Information, Geospatial Technologies, and Spatial Data Science for Health. To get you started, I have captured the essentials in my book. During this lecture, I will give a brief introduction to GIS, including the geospatial ecosystem, overview of analysis methods, symbolization and visualizations of geographic data, and then a little bit more about analysis. I will not go into too much detail on the data itself, as I have a separate lecture which you can view. We live in a highly connected geoAI-enabled society. In this center picture here, I've tried to capture the world in which we live. So, look outside your window and what do you see? You see buildings, you see trees, you see roads. If you live near a lake, you will see a lake. All of these can be mapped, and also sensors attached to different features in the environment so that we can monitor and survey what's going on, including us. If you're wearing a Fitbit or any other kind of tracking device or surveillance device or health monitoring device, all of these will be giving off signals that help you monitor your health. Thanks to these technologies, we can now start to take actions and monitor in a comprehensive way. Here's an example of being able to capture somebody who might have some vector-borne disease. A blood sample is taken, which is then analyzed, and the results can then, if there is a positive result, then further actions can be taken to minimize future risks by sending out appropriate response teams to reduce the infected vectors that may be infected in a particular area. So we can do this for other systems. For example, thinking of air pollution, there's plenty of sensors in the environment that are capturing the air quality. Knowing what the air quality is outside your house, you can then take the necessary actions to help protect yourself by wearing a mask, or if needed, take your inhaler so that you can minimize any asthma responses in different areas. Similarly, in areas where a particular flooding event may happen, knowing the extent of the flood event and the types of actions needed will help to reduce further risks in that environment. So how can we do all of this? The geospatial ecosystem is composed of many parts. We have the GIS and Earth observation software. We have the programming environment, which is Python-based, but also other elements in there, such as JavaScript, R for statistical analysis. And then we also have data and databases to house the information. So what kind of methods and analyses should we be thinking about? We need to be able to create and extract information. We need to be able to visualize and explore information, as well as analyze and make predictions, so that we can understand where and when something is happening, what kinds of risks are taking place in a particular space and time, who may be affected, and then how to intervene. Essentially, a GIS allows us, and the geospatial technologies as well as other technologies allow us to collect, extract, collate, manage information. We can then visualize it, and thanks to different GIS systems, we can interact with that data and layer that data so we can explore spatial relationships and see what might be going on in different areas. We can then evaluate and model and conduct a variety of analyses so that we can evaluate these interactions and relationships, as well as model these spatial relationships so that we can test and understand what might be going on, as well as make future predictions. Since many things happen across space and time, we also need to be able to examine what happens locally as well as globally, what happens in the short term as well as the long term. Often we will need a variety of data which is captured at different levels, at a granular level, so what happens where you are right now, but also more broadly at a more global level where information may be noisy or more broad. We can then take this information and we can examine observations, or we can create models so that we can make future predictions. A variety of methods are available that allow us to analyze different information as well as integrate information. Today, we need to be able to use a variety of methods that come from data science, spatial analysis, image analysis, citizen and social science, as well as, in particular, methods associated with different domains. Thanks to AI, machine learning, and deep learning, we can now integrate these in different ways and be able to mine and extract information that we weren't able to do before because of the large volumes of data that are now available. Here you can see a quick overview of the different aspects needed when analyzing geospatial information. We need to get data from a variety of sources. We then need to understand what is in that data. So we need to explore and understand our data. And then we need to think about what kind of analysis we would like to conduct and the methods that are most appropriate for conducting those analyses. And of course, being able to communicate and share our findings. Here I'll highlight a little bit more about spatial analysis and some of the methods that you might want to consider. Essentially, there are 6 functions or classes of spatial data analysis that include measurements, network analysis, topology, surface analysis, statistical analysis, and also the geoAI methods. In ArcGIS, a variety of tools are available. Here are 5 essential toolboxes to consider. These are for the surface analysis and the topological and network analysis and distance analysis. These include things like extract, overlay, integrate, looking at distance relationships between features, and so on. We can also analyze patterns, so thinking of the geospatial statistical methods, so that we can also further assess relationships. And then, of course, it's important to be able to manage and transform and convert our information. In QGIS, you also have similar tool sets. There may be some variation in how they're named, but again, related to geoprocessing, geometry, analysis for both vector and rasters, and data management. Now we'll move on to symbolization of data. Data comes in points, lines, polygons, or as rasters. Without symbolization, data is just that. By symbolizing, we can then add context and understanding to what is in that data and what that data represents. Without symbolization of geographic information, the information is just a series of points, lines, and polygons. We can provide meaning through symbolization, as illustrated with these different examples. But how to symbolize and what methods to use to classify data is a little bit more complex. Here are some examples of different types of ways that symbolization is used. For single symbols, we can categorize information, we can use graduated colors. And for each of these, the data can be classified using different methods. So in summary, we can create meaningful maps using a variety of symbolizations and data classification methods. For information on data, please watch the lecture on data. Otherwise, check out my book for an example of an analysis that you may want to conduct. Thank you.